one's gonna watch it. Anyways, what's up? Sup? So, gonna learn about the internet. You ready? Boogum. Boogum. I said boogum. Fail. Boom. Hello. This is what it looks like, the internet. So you don't have an idea of what the internet really is? You're all web developers. Send him.
I mean, so wait, capital I internet or lowercase I internet?
Not sure there's a difference, but try.
Okay, it's either the series of databases and wires and
Yes.
satellites around the globe that connect everything, and then there's the World Wide Web, which is the protocol or whatever that lets everything work regardless of system
Okay.
and browsers and stuff.
All right, that's pretty good. So the internet is just literally, and I don't use that phrase incorrectly. It's literally just a bunch of wires. That's all it is. Like from here to Poland to Tokyo to USSR to China back to California. It's just wires. That's all it is. Like wires that literally run throughout the entire world and crosses all the oceans. Seriously. So it's pretty intense. Like, who has moved here ever at all? One person? Have you ever moved before? Like, literally, like, oh, hey, I'm going to college. I'm going to, like, not be at my mom's house anymore. Yeah? Did you get internet? Did you get the internet? Yeah? And how did you do it? You called up Spectrum Wireless. Spectrum. And then they were like, yeah, no big deal. It's Tuesday. Today's Tuesday. We'll be there next Friday between the hours of 8 and 6 p.m. You're like, cool. Very specific appointment. All right. Why? They literally had to drill like a hole into your house and hook up your wires. Right? Because that's really how information gets sent and how it gets sent so quickly. And so essentially, the way the internet works is it's in these huge, high density, like, I'm not gonna say this because I'm not a science guy, polyethylene insulated wire. There's copper tubing, there's some like petroleum jelly, but essentially it's all this optical fibers, right? We have managed to reduce everything that gets sent, like every piece of data, right? All your cool, non-illegally downloaded movies, all your music streaming from Spotify, all the memes, down to what are known as bits, right? And that's like in binary, just zeros and ones. And they travel at the literal speed of light through these fiber optic cables all across the world. And so when you make a request to like google.com, you're literally hitting a Google server and it just sends you back HTML. And then your browser just renders it. Are there any questions on how like the magic of the internet works? So what happens now is like cell phone towers, they will transfer these through wireless waves to satellites, and then the satellites will just be like a relay system, and then it hits your phone. And then it goes right back and forth, back to the internet. And so that's how like the wireless world works. That's why whenever you get a cable, you basically have to buy a router, right? You have to take that hard line that's coming into your apartment and it has to transfer it wirelessly over a certain specific frequency that you should secure that, and then it goes right to your phone, and then you're on Wi-Fi. Does that all make sense so far? Nothing wild and crazy? All right, cool. How did you guys like your demos last week on Friday? Your CLI projects? Are they cool? Whose demo went like perfect? Oh yeah, everybody. Yeah. Demo went perfect. So the way it started, right, and I'll show you little cool graphics here. This is like your only lecture where I won't do like a lot of coding. It's probably because I'm a bad developer. All right, I'm just gonna show you already. So what do we got? Like the ARPANET. Boop, boop, boop. That's not what I was looking for. ARPANET. Cool. So this right here, right? Where's the wiki for it? This is basically like the foundation of the internet. It's just a bunch of networked wires. You don't have to like take notes, it's okay. But if you want to. But yeah, this is really about it. Originally, it was between like Stanford and UCLA. There was like this one long wire that connected them. And what they've discovered is they wanted to send a message to each other. They wanted to be able to communicate and send data across this big wire, right? From one computer to the other. And so naturally, their favorite word was login. They were like, oh, I'm just gonna send login. They didn't have like authentication or password protection yet, but login works. So they started to send L, and they started to send O, and then the server shut down. So the first text message, fun fact, is LO, L-O. First text message ever. It's not sexy, it's not an eggplant emoji or anything like that, but you know, it'll do. And essentially, we started adding all of these extra schools, right? So the reason Facebook originally was kind of like only collegiate is because the higher institutions that needed to transfer all this knowledge between each other are the first ones that really got on this network of all these different computers. And so they can basically have a digital library and catalog all of each other's information. And this grew, and man, I want some history lessons over here. That was back in 1969, that first text, like a long time ago. I'm not gonna like make anyone feel old, but it's a little bit older than me. And so a gentleman by the name of Vinton Cerf, C-E-R-F, invented something called the TCP. Does anyone know what that stands for? I've heard of that before.
TCP.
Yeah, the TCP. The TCP, like D-A-T-C-P. No, not really, just TCP. You heard of this before? You guys never seen this? Like, literally TCP, all right? Tango, Charlie, Papa. Boo. Does Mike do that when he like does his lectures? I do this all the time. It completely ruins the recording, but it's good. So this stands for something called Transmission Control Protocol. And all that means is when you are sending data over the internet, I don't want to make anyone feel old or young, but back in the day, like you had like dial-up. Does anyone know what this is? Like, Mom, get off the phone, I'm online right now. Does that make sense to anybody? Okay. Do you remember when you would download pictures and it would load like pixel by pixel, like line for line, right? And it would like, and be like just line for line. So the reason it loads that way is because of something called TCP, right? There's a certain way it breaks down, it sends it through the wire, and then when it comes back, it has to reassemble it in the exact way, in the exact proper way. So it doesn't just come back randomly. Does that make sense? So essentially, for what you need to know right now, and I guess it's kind of extra, that's really what it is. It's a protocol that breaks down the data specifically in a specific order, and then when it gets sent and beamed through, it comes back in a specific order to be reassembled. Right? Is that cool? And those pieces of data that you send through are known as network packets. Right? They hold, I think, like 8 bits of data per network packet, and like, no, one bit of data like is like a network packet, and then like 8 bits is like a byte. And then you have a bunch of bytes, like a megabyte, and then gigabyte, and terabyte, and then all of that gets really expensive, and so I don't know what it's called after that. You know what I'm saying? Newegg prices are ridiculous. No? You guys don't shop? All right. Thank you. Thank you, one person that buys hard drive space. All right, cool. So naturally what comes up with TCP is a partner phrase called IP. Does anyone know what that is? Yes, Internet Protocol. So TCP, in conjunction with IP, is that whole process, right? But IP also refers to something known as like your IP address. Also, back in the day, this is like history stuff. Who here has like memorized someone's phone number, not their own? Oh yeah, okay, cool. I'm talking to the right crowd here. When's the last time you used that number? Yeah, exactly. This is what you do, right? You pull out your phone and you're like, yo, check it out. I'm about to text Bae real quick. Do you like put in like his or her number, or you just go BAE and then like immediately you start calling and then BAE comes up as like the number You know what I'm saying?
You can choose like the 5 days stuff.
Huh?
You can choose like the 5 days stuff.
Oh, you're right. You're right. Smart. You gotta pick the right one, right? No, but like, let's say you call mom, right? Just MOM comes up. Like a phone number doesn't even come up anymore because we don't really use it. And the IP address, think of it as like your phone number, right? So each one of you individually, when you log in through the router, you get assigned your own IP address, and that tracks who you are in that session for that router. All right, does it all make more sense when I do like this diagram? And then I'll like really break it down for you. But that's kind of like just what I need you to like conceptually understand for now. Is that cool? All right, so your IP address is like a phone number. Yep.
That LO message that was sent in 1969, was that sent through the phone line, sort of?
No, it was sent through like this like large, huge
No, but I
fiber
mean,
optic
that-
cable.
Okay.
Yeah, I mean you could say it was like a phone line.
But it wasn't the phone line. It was
The phone line?
in war games, he would use.
Oh, okay. You mean that very real non-fiction movie War Games? Okay.
Well, in that movie, he's authenticating using a black box to get off the digital signal. The phone lines and the lines crossed over a little bit, but there's also legal distinctions, and they have to use telegram lines for certain places.
Is this where we get all our facts? Movies?
Oh, not all, but.
Okay, great. Listen.
I prefer Fox News, but it's just
Okay. Very good. Very good. Yes. Nice. All right. Did they report on the status of our relationship with Wakanda? No.
nice.
Not yet. Cool. So, all right. So, a gentleman in 1991 by the name of Tim Berners-Lee, who is still alive, by the way, and just like a side note, is inventing like the new internet. So he's the father of the World Wide Web, right? Once we realized that we had something like this, we would want to be able to add any person onto this network and have them experience what are known as like websites. So who can describe to me like what a website is? It's a little tricky, right?
It's like an IP address you can access.
Okay, sure. It's like an IP address that you hit, right? And you access? Anyone else? Go for it.
I don't know, like,
Did this come from a movie?
no, like,
Okay.
it's like, I mean, a lot of the earlier ones were like controlled ways for people to access databases. I feel like that's basically what a lot
Okay.
of it boils down to.
So did anyone see what happened here as it's loading all of these things when I went to CNN.com? All right, go to everyone's favorite news source apparently. Is it just Fox or Fox News? Fox 5? All right. So what's happening here? When I do fox5ny.com into this little URL search bar,
It's like converting that into like whatever IP address is located like to the server, and then your IP address goes to that and like asks for that information that's located on that address, and then it gives it back to you, like what that address.
absolutely. Who's seen this before? What this thing does, all right? It's like mind-blowing the first time you saw it. You're like, oh damn, all right? So it's known as like the inspector, and you can essentially look at the entire source code of every single website that exists, right? And what this really is I think I have a link for it here somewhere. Oh my God, I'll get to that in a little bit. Boop, boop, boop. Where is like the first website ever? No, it's okay. So what's happening is I go to Fox5NY, right? And I make a request. And I'm trying to get information from fox5ny.com. And what happens? It hits like their server, and their server is going to send me back a response. And that response is going to be this doctype.html. And so my browser knows what this is and can then interpret it and render it properly based on the CSS, the styling, and the tags that are sent through, right? Like I know with these divs, right, I'm gonna get something. I know like in here, like with this section, God, this is so nested. Oh my God, oh my Lord. And essentially, I can look at anything in this page, and like, look, I could see this A tag, right? What, do you remember what this is? The anchor tag? It just means like a link, right? That I can go and click this, and it's gonna send me to this video, this live video, like website. Does that make sense? And then if I click this again, I'm making a new request to get information. So for the purposes now, I'm just gonna start saying get request. Is that okay? So I'm gonna make a get request to this new link, right? And this HTTP right here, this beginning, is simply the protocol, right? There's other protocols out there, right? Like SMTP for like mail, like email. But for HTTP purposes, like this is the protocol we're gonna be using for like the web. This www all the way to the .com is the domain. So when you have to register eventually, when you graduate this program, you'll want to like probably register your own website. Like I have evanswayne.com, not Chef It's Your Boy Ardita. Oh my God, I'm gonna buy that. Please don't buy it before me. Shouldn't have said that out loud. That's what is known as like the domain. And anything after that, right, is a path or resource. So from now on, if you hear me say domain, I'm just going to refer to this beginning part. If I say path or resource, it's going to be anything after like the .com, the .edu, the .net, the .org, the .io, the .co, and I ran out of things, right? Was that cool? So far, so good? All right, so like, let's take a look. See, network. What it's going to do is it's going to download all of those assets and resources. Like, let's go to live video. And look at this. Holy shit. Oh my God, it's still going. So look at all these requests, right? I downloaded basically all of these, and it happened within 1.6 seconds, something like that. Most of the page rendered in like 4,000 milliseconds. Oh my God, it's crazy. So each one of these things inside my HTML, right? Like in this head tag, I had to download this script, I had to download this JavaScript, right? I had to download all these scripts, and eventually I get to like some CSS in here, and then I download anything in here, right? Like this image tag, I have to actually go to this source, download the image, and then render it back on my page. And that's what the browser is doing. Does that make sense? So far, so good? All right. So this is obviously a lot more advanced, but Tim Berners-Lee, before like image tags came out and all this, he just had like table rows, like unordered lists, p tags, h1 tags, and decided to make like the first website, the first web page, just to render some information. So anyone that went to the right domain and URL and path could see it. He thought that anyone can upload all of these HTML documents and essentially create a network of these websites. And so the World Wide Web was born. Does that make sense? It was just utilized to share information through a common language known as HTML, right? Hypertext Markup Language. Did I lose anybody? Pretty simple stuff. Cool beans. So, it's funny. So what's the greatest threat to the internet right now? Yep. Cool. It's not net neutrality, although you're close, very close. Anyone? Just like a wild guess. That's right. No, actually, it's sharks. So the internet is basically made up of these wires, and here's a video. For whatever reason, it turns out, see, this is like the giant internet wire, like right here, right there, and sharks just like biting it for no reason. They go town. So the greatest threat to the internet is sharks. Yeah, and that's like the fiber optic cable that gets run through all across the world. Yep.
Actually, I read recently too that just with the climate change, global warming, everything, there's so many of these wires on the coast that
Yes.
there's danger of flooding and losing a lot of this network.
Yeah, and so a lot of like the environment issues are like the biggest threat to the internet. Because I mean, if the wire is kind of cut, you're screwed. You know, that's it. That's game over. 1 star. No bueno. But yeah, so I have this sweet GIF, Batman saving us over here. Have you ever seen this movie? Oh my god, what a time to be alive. Anyway, so sharks are the biggest threat to the internet. Hope you learned something today. All right, cool. All right. So let me explain a little bit more about like what I mean by these requests and how that's happening. I'm gonna tie in like the IP address. All right. So I got these like sweet graphics all set up for you. All right. Boop, boop, boop. I'll just get rid of this before it plays music. Cool. Doop, doop, doop. That's all those images I opened up earlier. Cool. All right, sweet. So here's how it works, right? So boop, boop, boop. Can everyone see this? All right. So this is you, all right? Who's heard the term client before? What does it mean? Yeah, for now, all right, we'll just refer to the client as anyone that is making the request. All right, so if you're on like Safari, boo, or like Mozilla, boo,
Or
Opera. Remember Dolphin browser? No, I'm kind of old. Anyways, like the client, right? So you're on like Google Chrome. You're on like, God forbid, Internet Explorer. It's actually okay if you're like downloading Chrome, but
I mean, Edge is
Edge is supposed to be faster than Google Chrome.
on, yeah, on.
Cool. So the client, right? That's basically, for right now, that's you, right? You're the client. You're making these requests, and you want to go to a very, very not dated or completely relevant website, AOL.com, right? But how does like certain things like email work, right? It's easy to kind of like make a request to like CNN or New York Times or like Reddit, and then kind of understand what's happening. But you as a client, right, are you directly connected to the internet? Who's got like a hard line right into like that giant internet wire? Nobody? You?
No.
That's impressive. So, that's why we need someone to give us access to the internet, some sort of provider to the internet, some sort of internet service provider, right? Who has heard that term before? And that's what that means, right? They are hooked up somewhere to this giant network of wires. And what they'll do for a nominal monthly fee is they will give you access to that giant wire. And so what they'll do is, on your client, all right, this just says DSL, it could be cable, could be fiber optics, doesn't really matter, right? However, you're hooked up to the ISP. So what you'll do is you'll go on and you'll just start hammering away, right? You want to email Aunt Ruth, right? Totally normal Chinese name. And I want to email Aunt Ruth. And so I'm going to compose an email. I'm going to open up my browser. I'm going to go to Gmail. And I'm going to like hack away and be like, yo, Aunt Ruth, what up, fam? It's me, Chef. It's your boy RD. Miss you, my dude. One love, peace, party rock, Wang Chuan out, right? And then it hits the ISP. So this email goes from my client, from my home, to the internet service provider, which they definitely don't read for privacy reasons. And then it goes to what is known as like the internet, right? It gets routed to the internet. It hits the Gmail server. And here Gmail has to do something. It has to find who Aunt Ruth is, right? So it's usually something like Auntie Ruth 4567 at AOL.com, right? The at AOL.com lets me know the domain that it's in, so I understand where it should be going. It should be going to the AOL servers, right? So what it's going to do is it's going to go process this email. It's going to go back to the internet and look for the AOL servers. It's going to come in, find it, and it's going to sit right here on the server. And so when Aunt Ruth wakes up at 5 o'clock in the morning, that's when she likes to get up, she will log in to AOL, right? And it will say, you got mail, because that's what it does. And she will connect through these hard lines, like who's seen this before, right? These things. And it will connect to, eventually, the AOL server. Then she will download the email, and then she'll be like, oh wow, my favorite nephew? Sorry, I should have thought that through. Is like sending me an email. This is awesome. And that's like how the internet sort of works. Right? It needs to find these things, it needs to find the route, and then it needs to go and send that data. Is that cool? All right. Any questions on this? It's going to get significantly more complicated. So here you are, right? Boop. Boop, boop, boop. There you go. Let's just say you're on the same network, right? Like you and I are all on the same network. We're on flatironschool.com. Flatiron School Wi-Fi, rather, right? And let's just say my boss that sits like right behind me is doing something and he's on like this cool website like marketresearch.com. But I need to go to Facebook. How is it that when I or my boss, right, sends a request, that when it hits the ISP and then it knows which request goes where and which request comes back to me properly? Like, in theory, there are all these requests that go out and all these requests that come back. How do we know that I, going to facebook.com, never received marketresearch.com because somebody else on my network is making that request? Yes, sir.
Your IP address.
Yes, that's very helpful, but there's more to it. Anyone have an idea?
Your IP address, which is the NAT's IP address, and then your port.
That's useful too. And I'm gonna get into that here in a little bit. So this is what really happens, right? Your IP address, you, the client, Chrome, and your boss, client, Chrome, makes a request to either Bookface or Market Research. It's gonna go through what is known as the router, right? You guys know what this router is? It's like really expensive, and it just lights up every once in a while. When the lights are off, you just plug it in, plug it out, and then like your internet works again. What that's gonna do is it's gonna determine, right, through your IP address, it's gonna remember who made that request and to what. It's going to hit something called like a DNS server, and what that does is it determines, right, remember I talked to you about your IP address being like sort of like a phone number, and then nobody uses these phone numbers anymore, that you just go to like Bay 1, Bay 2. Man, what a world we live in, right? I don't have this, but sure, right? You just basically look at like the name, and then it comes back correctly. So the DNS server is going to determine if I go to facebook.com, what is the IP address for facebook.com? Because the computer doesn't really care that it says Facebook. The computer doesn't need to know something that's human readable. It just needs to know the actual information that it's trying to get. And so it will hit the DNS server. The DNS server will basically store all of these different URLs, right? Either facebook.com, Gmail, Macy's, CNN, and it will tell you what the IP address for it is. Once it has an IP address, it's going to hit that server. That server is going to get that request, process it, and then send you back a response, which is going to be the HTML. So what it does is, it's going to hit the DNS server, the router, hit your ISP, connect to the internet, determine where it is that you want to go, like Bookface. It's going to send you back the response through this, through the router, through the ISP, back to the router, figure out who made the request, and then send it right back to the person that made the request. Make sense so far? So what I can do is I can easily go to, right, like Bookface. I don't have a Bookface, so it's not going to be logged in. Yeah? But I can also do something called network utility. Does anyone know what this is? All of the Macs have it, like built in. And what you can do is you can do trace route. You can easily look up any website, hit trace, and it will break it down for you, right? I started trace to facebook.com, and I got some weird IP address, right? This IP address, I can easily just close this, open a new tab, go to the IP address, and it will render facebook.com. right? So all the IP addresses really kind of point to a more human readable version. And that's what the DNS server does for us. We put in the human readable version, it breaks it down, it tells us the correct IP address, then it goes to that server, right? And then it sends back a response. So the request response cycle is essentially, I hit this sign up, I hit the server, and then it sends me back a response, right? I go to a different website, I hit the server, and then it sends me back a response. So there's like a request and a response lifecycle that's always happening in the internet. Yeah? So far, so good? Cool. All right. I want to show you a little bit more about the magic of the internet. Who knows what MDN is? No? It's MDN.
It's like a resource, learning how to HTML, CSS, JavaScript.
I know I kind of like pooped on Mozilla and like Firefox, but MDN, the Mozilla Developer Network, essentially are the people that like run like the internet and the rules in HTTP. And so what you can find is, you can find HTTP right here, under their technologies, under their docs, right? Which are very useful, which you will know and love. Who remembers the Ruby docs? So good, all right? So are these. So we'll go to HTTP. And here on the bottom, you'll see something called request methods. These are all the methods that you can execute within HTTP. What I mean by that is, I've talked about one so far. Which one did I talk about? Anyone? Anyone just wild guess which one I might have talked about already? Which one? No? Nobody? That's right. Get, right? So there's a GET request. And what that does is you're just going to get information. So why would I need all this other stuff? Who knows? To do other kinds of requests. Very good. Good guess. You guys heard of a term called CRUD yet? CRUD. What's CRUD?
Create, read, update, delete.
Yes, create, read, update, and delete. There's only 4 things you can do to data. You can make it, all right? You can read it, you can like alter it somehow by updating it, or you can just blast it away. It's really about it. There's nothing like sexy or magical about it, all right? So far, so good? So naturally, if I'm making a GET request, what am I really doing? Of the 4 CRUD functionalities. I'm just reading. I'm just asking for information, and it's going to spit me back HTML, and I'm just going to read it. I'm just going to view it. But what if I need to create data, right? Like let's say I'm on Bookface, right? And I'm like, you know what? I don't have an account, right? Chef, it's your boy RD, right? And here's my number, 867530099. Nobody?
Yes.
Jenny.
Thank you. It is Jenny's number. What up? Anyways, my password is password, very good, secure. And I hit sign up. What kind of request would this be? In regards to what is it that I'm trying to do with data? If I'm trying to sign up for Bookface. Facebook, I'm sorry. It's a bad habit of mine.
Post.
Yes. I'm hitting something called post, but what I'm really trying to do is I'm trying to create a new user, right? So if you remember back in like the SQL days, I'm just basically creating a new user in my users table, right? So what if at some point I realize how silly this is, and I'm like, no, listen, I need to enter the corporate world. My name's Wang Evans, proper nouns, right? And I'm like, all right, I'm like damn near 30. I'm gonna enter the corporate world now. I can't be Chef, it's your boy RD anymore. No one's gonna hire me. So I need to edit or update this functionality. I'm gonna send a new request, right? A different type of request. And then what if, let's just say I get a job as a teacher and I know my students are gonna look me up and I'm like, F that noise, and I need to delete my Facebook account. What kind of request should I be making? Some sort of like delete request? Does that make sense? So the main ones you'll be using, right, is get, which is to read, right? You'll do something called post, and that's when you send like parameters, right? You're gonna send data across the internet. Those parameters could be like the name, the email address, my password, my phone number, so that the server can do something with it. It's going to do like insert into users table, something, 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 and then it's going to forward me back what? More HTML. After it created the table, it's going to forward me back some new HTML that's going to be what? My profile page that says, hey, loser, make some friends. Right? Like you have 0 friends right now. Good job. I have a brand new account. Leave me alone. So that's what post does. Patch and put are your update HTTP verbs. So what put does is, in your table, do you have more than one attribute sometimes? Sometimes you have more than one attribute, right? Like in my users table, I have like a name, an email address, and like a phone number, right? If I wanted to wipe that entire record and update it with all brand new information, I would be putting a new record in that place. Does that make sense? Like I'm changing all the categories of it, and I'm replacing it, and I'm putting a new record in that same place in my table. But if I wanted to just change the name, because my phone number stayed the same, then I would be what? I'd be like trying to patch it up a little bit. Like if you think of like a record, and if you just like wipe the name and then put like a new one in, you're just like doing a little quick fix, all right? A little patch. So the difference between patch and put is essentially whether or not I'm replacing the record or if I'm just like kind of fixing up a small part of it. So both are like update functions that are kind of key and important. And that's really all you need to know right now. Get, post, put, patch, and then our favorite, delete. You're just going to blast it away, all right? Like Facebook is so 2006. It was fetch, right? Stop trying to make fetch happen. It's never going to happen. Cool? Questions so far? Man, this class is so fast, so smart. All right, there's like one more thing I wanted to go over. I can't remember what it is. I think I zoomed in too much on this. Cool. All right, yeah, and rack. All right, so now let me teach you about rack. So is everyone cool about like DNS servers, IP addresses, routing, GET requests, response lifecycle, HTTP verbs, where to find them, what they mean, and CRUD? All right, so let me show you a little rack. Who did all the pre-work in the labs? All of you. So proud, so proud. All right, so what I have here, if I can open it. All right, cool. Oh my God, Batman's out of control. There's like a really good student-facing README here that I'm gonna upload for you. It goes like into a little bit more detail, but like that was like the highlights, the majority of like what's important, and I just want you to get like straight to the labs. That's cool. So we're gonna build something with Rack, and Sinatra and Rails are both built on this framework called Rack. What it is it will take a small part of your hard drive, and it will start up its own internal server that you can then make your own GET requests to, and sort of simulate a website. Does that make sense? The code is all good, and it will work, and it will run if you were to deploy it to, say, like a real-world server, and it will render exactly the same. So this is like what we'll build in development while we're here, and then toward the end of Mod 2, if you want to, I'll teach you how to push it up to the internets and the cloud, whatever that means, and it'll be live. That work? Awesome. So first thing you do whenever you get a new code base is you should read and understand how that app works. So this one's pretty small, so I'm just going to go through it. All right? Does this look familiar to you? Should probably not keep going. Oh, I missed. Cool. Does that look familiar? Should all know this. Any questions on this? I'm just making a new song class, just going to hold all of them, and there's like a title. Very, very complicated code. All right. I have a gem file. All right, you talked about gems already? Yeah? Cool, so I'm going to bring in something called rack and something called shotgun. In my config RU, I'm just going to require rack. I'm going to require app, which is going to be my whole application. And all I'm going to do is run this app. That's it. So naturally, in app, right? Who's seen this before, like this namespace? Raise your hand if you've seen it. Now it's like dark and scary. All right, cool. So I wrote some code in here so you have an idea. Basically, there's like a module called rack, and in the module, there's a class called request, and it initializes with some sort of like environment hash. We won't really get too much into it, but you can take a look at what the environment is later if you ever wanted to just do like puts environment. And it'll print it to the console, and you can kind of see what's going on. So I'm going to bring in my song class. Here I'm just going to do a method called call, right? And that's the default for like rack. I'm going to open up a new request with the environment hash, and I'm going to have something called a response. So I made these like handy dandy notes for me, these to-dos. So who's listening to music right now? Like what's like a cool song? What's like a new, good song? Anyone? All right. Cool. Any other cool songs? Anyone listening to?
1,000 Miles,
Oh my God, such a good song. Anyways, we just sang that at karaoke, then you missed it. And now I wonder. Anyone else? Any cool songs? Okay. All right, I can tell this class is going to be so good at feedback, just so good. All right, so all I'm doing is I just made some new songs, right? If the path matches something called songs, then all I'm going to do is I'm going to map over, right, all my songs, song.all, and I'm going to create a new list item tag. I'm going to join them, and then in my response, I'm going to write H1, like a H1 tag, and it's going to be like, yo, this bomb song list. And in the unordered list, I'm going to have each one of these list items with song.title. Is that cool? Otherwise, if my path matches artists, then I'm going to, in the response, I'm just going to send an H1 tag that says, this is the artist list. And if it doesn't match artists or songs, I'm going to have some div that says not found and maybe render an image or something. And I have to finish the request. All right, just like in Ruby, if you def something and you like def a method, you have to end it. Or like if you start an if statement, you have to end it. In the response, you have to open the response, do something, and then end the response. Is that cool? So let's see it in action. I'm gonna do a little bit of this. Config dot, oh, I'm sorry, it's rack up. I did that already. Oop. So notice the port that I'm listening on, all right? 9292. When you get to Sinatra, it'll be on 9393. So just a little heads up. I'm just gonna go to localhost 9292. And boom, it's this guy. This winner right here. This is the image I chose. Why am I getting not found? Why am I getting this? Oh no, the server's up. That's why I'm getting this. Otherwise, I would get internet connectivity issues or like the little dinosaur or something.
You can specify artists or songs.
Yes. Here, I'm in the domain of localhost. Right? And if you remember in my code, I said only if it matches songs do something or artists. Otherwise, not found with our boy. So naturally, because I didn't hit any of those paths, any of those resources, then it's going to serve me this, right? So let's hit it. Send it. What you got, man? Yeah.
What's that equals tilde?
I'll show you in 1 second. So artists. And it just says artist list. This is my H1 tag that says artist list. That's it. So I wrote it both ways, right? In case you ever see it. So I can do path.match, or I can do this like equal tilde, which is like, it basically should be this, right? This is like sort of like a comparison operator where it says it must be this. It must match. Cool? I'm going to show you a bunch of these things.
Was there to do that?
What do you mean?
Because you're saying like ask them that, right?
Oh, it's because this request.path is what type of object? It's a request object, right? So I don't want to overwrite the double equal sign. I don't want it to be exact. I'm going to use a new method that I built called match. And I'm going to take in like a string or a regular expression so that I can then interpret it. So this is like a unique method to the rack. Okay, cool. Good question. So let's hit, oops, just kidding. Bloop, bloop, bloop. Let's hit songs. Oh wow, I did it like a lot of times. I'm gonna look at the code later. But the important thing is, it's rendering all these like song list items, right? So what kind of website is this? Is this a static or dynamic website? And do you know what the difference was?
Static.
Okay.
Because you can't call, something like you can't like customize it for each one. Like if you had to call it each song, you would have to change the URL for each song.
Interesting. Okay. Any other ideas? It's really close.
If it's static, so you're only doing get requests and you get information.
Okay. So there's a confusion about static and dynamic, yes?
If you wanted to change the output, you actually have to go back into your code, change it, and then refresh.
Okay. So here's the difference, and I like the guesses, right? So you should keep those going. And this is like my fault for not explaining the difference. So the static website, right? And here I'll show you one that I built, right? This is a static website. It literally does nothing except render information. This website will never change unless I hard code data directly into the HTML, right? I mean, this is like a form here, but this data never changes, right? Whereas if I were to go to CNN.com, will this exact website look the same tomorrow? Do they change all the HTML every single day? Right? So this is what is known as like a dynamic website. Meaning, if I am pulling my data from some sort of database and rendering based on the database, I would consider that dynamic. Because I don't have to change any of the HTML. This will change whenever song.all changes. Whenever my data changes, it will render different things within my browser. So I would consider this a really, really crappy dynamic website. Only because it's loading from something else and rendering based on a database. Otherwise, right, in order to change this to a static website, I would literally do this. Instead of song.new, this isn't even important anymore. Data's not important. This is trash. This is trash. And then I would have to do this. Every single day, I come up with a new hit song. All right, I have to do this. Oh my God, this is painful. All right, hit me, baby, one more time. And then some other cool song, right? Another cool song. And then like tomorrow, if you're like, oh, hey, by the way, we have a new song. Like, God damn it. Right? Like, hate my job. Right? This is a statically rendering website. Do you kind of see a difference? So one is coming from a database. Otherwise, I'm like hard coding every single thing in there. And that's kind of like what Rack will do. We won't really deal too much with Rack. This is just so you understand what's happening under the hood, so you can start your own server. What we'll do is after, you'll finish your discussion questions, and then you'll jump right into Sinatra, and you'll learn about MVC and how that model works. Are there any questions? Cool, that's all I have for you right now.